Okay, here we go. 2.4, guys, complex numbers. You did this in Algebra 2. I know I've said that before about a lot of stuff we do, but I know for a fact you spent a few days on this. I was actually talking to Miss Glick today at lunch, and she's like, oh my gosh, we do this all the time. I said, I know. So we're talking about imaginary complex numbers, right? We have real numbers and we have complex numbers. Complex numbers have imaginary parts. That's the I. The imaginary unit is the little italicized I. When you take the square root of a negative number, you have to pull out an I. If you have I squared, it equals -1. And we'll talk about this as we go. All right, when you have a complex number, you have two parts to it. There's a real part and the imaginary part. How can you tell the difference between the real part and the imaginary part?
There's an eye on it.
There's an eye on what?
The imaginary part.
There you go. The real part will go first. It's always going to go in front. And then the imaginary part goes second. It has the eye on it. Okay. That's what I just said. So look, all numbers are complex. If you have just a regular whole number, like 3, and there's nothing behind it, you can assume, or you could say that it's plus 0i. Same thing if you had just a plain imaginary number, you could put a 0 in front of it to make a complex number. So there's always two parts to every number. You just don't see it all the time. So if I asked you to simplify this, express as a multiple by, what is the square root of 16i? Sorry, square root of negative 16.
4i.
Yep, this would work out to square root of 16 and the square root of -1, which would be 4i. If you had like this, and I said, what's the square root? What would it be? It's 4, but what? Positive and negative. See how the house is already on it? That's why it's just 4i. If you physically put the square root sign on top, that's when you have the plus or minus. All right, in this case right here, that 2 is distributed to the 7 and to the I, correct? So 7 squared is 49, and I times I is I squared, correct? We would then cross out I squared and make this what? -49. Remember that? Okay, good. All right, when you guys are adding and subtracting complex numbers, it's the exact same thing, guys, as combining variables. Looking for like terms, right? God bless you. Could treat I, God bless you, as a variable. So I look here. I have 7 plus 4i minus 9 minus 5i. What do I have to do first? Distribute. I have a minus sign in the middle, so we got to change the sign, change. Now, literally, real goes with real, imaginary with imaginary. So 7 minus 9 is what? -2. And then 4i and 5i is?
9i.
So plus 9i. And that's how you write it. Get the real part first, imaginary part second. All right, look at the second one. We're adding. So do I have to do anything with distributing or anything?
No.
Nope, I just said distributing. Weird. So I take the real parts. What's 8 plus 17? One more time. 25. And then I have positive 3i and a negative 7i. Minus 4i. That's it. Yes? Okay. All right, now if we're going to multiply, it's the same thing, guys. The only thing you got to remember is when you have I times I, you replace it with -1. I squared is -1. So if I FOIL this, what is 3 times 6? 18. Good. What's 3 and a -2i? -6i. What's -5i and 6? -30i. And then what's -5i and -2i? Plus 10i squared. Now, some of you are, can I already change it? Okay, fine. I like to write it out like this so I see. As soon as I see an I squared, I cross this off, and then that pops up. I cross this off, and I change the sign in front of it. Because when I multiply positive 10 times -1, I get -10, right? So what will happen when you FOIL, guys, is your I squared will cancel out. It'll turn it into a real part. So then you have 18 minus 10, which is what? 8. And then you have -6 and -30i. -36i. Some of you, can I just do it before? Okay, fine. I just think it's a better idea if you write out your work, just so you don't make any mistakes. You good? Okay. What does this mean? 2 minus 3i squared. You say 2 minus 3i times 2 minus 3i. So FOIL, what's 2 times 2? 2 times negative 3. Negative 3 and 2? Negative 6i. Negative 3i, negative 3i?
Plus 9i squared.
Plus 9i squared. Some of you right away go, oh, minus 9. Okay, fine. I just would prefer that you write it out now so you don't get confused. Change this. So my positive 9 becomes negative. So I have positive 4 to negative 9. Negative 5, good. Negative 6i, negative 6i? Negative 12i, good.
I have a question.
Hmm?
You always change the sign like it goes.
If it was negative, it would become positive. Yep. Because you're just multiplying whatever that number is at the end by negative 1, which is just going to change the sign. Yeah. Good question. All right, conjugate. Guys, it's very important to understand what the word conjugate means. This is a really easy concept, but you just have to understand. The conjugate of A plus BI is A minus BI. The conjugate of A minus BI is A plus BI. What is changing?
The signs.
The sign in the middle. That's it. The sign of A stays the same. The sign in the middle is what changes. So when you multiply by a conjugate, the reason you do that is to get rid of all the i's in your answer. You just get out with a regular real number. So let's look at some examples of this. So if I ask you, what is the conjugate of 7 minus 10i? You would tell me it's what? 7 plus 10i. If you multiplied these two together, 7 minus 10i, 7 plus 10i. And we do this because of division. You'll see in a second. When you multiply, guys, this is just the difference of perfect squares. It will turn out to be. Right? It's the same exact parenthesis. You just have a positive and a negative. So your middle term will cancel out. So what's 7 times 7? 49. 7 times positive 10i.
70i.
Plus 70i. Negative 10 times 7.
Negative 70.
Negative 70i. And then negative 10i, positive 10i.
Negative 100.
Negative 100, what?
I squared.
I squared. Watch what happens. Positive 70, negative 70. Do what?
Cross it.
I squared becomes?
Negative 1.
So this becomes positive. So you have 149. Every time you multiply by a conjugate, the i's will cancel out. You'll be left with just a real number. Okay, so if I have this, and I say, what's the conjugate? First, you should rewrite it. How should I rewrite this?
6 in front.
6 in the front. So it's 6 plus 3i. What's my conjugate?
6 minus.
6 minus 3i. If I had this, negative 4 plus 2i, what is the conjugate to negative 4 plus 2i?
Negative 4 minus 2.
Negative 4 minus 2i. The only thing that changes is the sign in the middle.
Is it possible to have 3 terms or is it just 2?
No, because you'll have a real part and an imaginary part. There's no like third dimension, because if you had like 2 reals, you would just combine them. 2 imaginaries,
Oh,
just
yeah,
combine
yeah.
them. Okay, scoot. Complex numbers in fractions, right? You cannot have what number in the denominator? A 0. Another thing that is against the law to have in the denominator, hi. Good luck. Another thing that is against the law to have in your denominator, guys, is an I. Okay? Cannot have an I in the denominator. So, if we have something like this, let's look at B. In order to get the i's to cancel out, what did I just tell you multiply by in order to get the i's to cancel out, and then you have just the whole number?
The conjugate.
The conjugate of the girls' denominator. So I'm going to look at only the denominator is what matters. What is the conjugate of the denominator? 5 plus 9i. Guys, what you do to the numerator, you do to the denominator. What you do to the denominator, you do where? To the numerator, and vice versa. That's ugly. Let me rewrite that. You will definitely have a problem like this on your test. Definitely have a problem like this on a quiz. This is a long process, but it's really easy. You just have to pay attention to what you're doing. You have to remember to multiply by the conjugate. If you don't remember to do that, the whole problem's wrong. So now let's just simplify the numerator and the denominator separately. You don't have to do it this way. I just like to keep everything organized. I'm going to do the numerator. What is 7 times 5? 35. What is 7 times 9i?
63i.
Okay. What is 6i times 5?
30i.
And what is 6i times 9i? Plus 54i squared. I agree with you, Kelly and Francisco, but I'm just going to write it out. Now I'm going to do a little more cleaning up. I squared becomes what? So I'm going to cross that out and make this negative 54, right? So that I can combine 35 and negative 54 and get what?
Negative 19.
Is it negative 19?
Yes.
Okay, I'm just going to go with you on that. Then I can do what with my I stuff?
Add them together.
Okay, 63 and 30.
93.
So plus 93i. Anybody have questions about what I just did there? I just foiled. Okay, let's do the same thing on the bottom. We'll do the denominator. 5 times 5. 25. 5 times 9i.
45i.
Good. Negative 9i times 5.
Negative 45i.
And negative 9i, positive 9i.
Positive.
Minus
It's minus
81i squared, right? Again, I knew you were going to be the ones going to, I just did it in my head. Okay, fine, do it. But a lot of us can't do that. We want to see it. So let's go through the motions real quick. What do I do with I squared? I cross it out, and then negative 81 becomes positive. What is 25 plus 81? 106. And what happens with a positive 45 and a negative 45? They cancel out. What did I tell you is against the law to have in your denominator? I's. Did I get the I to go away? Yes. So it's important, guys. If you multiply by the conjugate, that will happen. If you don't multiply by the conjugate, you'll get a complex number.
So for A, you multiply negative 5i?
Yes, you could just do 5. Or you could just do I. You won't have any simple ones like that. That's why I just skipped it. If, just for chance, you came out with something like this, like negative 10 plus 16i over 2. Don't leave that. What do you notice? This is the same as negative 10 over 2 plus 16i over 2, isn't it?
Yes.
Can you simplify?
Yes.
Okay, you guys need to make sure you check to see if answers can be simplified. Just make sure. Don't lose little points on stuff like that. All right. Cross that out. All righty. Okay, we're just talking about simplifying. Okay, we're going to treat this like it was a normal problem with radicals. I'm going to show you the long way to do it just so you can see. The first thing I'm going to do is take out a negative 1, and then I'm going to break this down. What times what is 54? Perfect square and a non-perfect square?
4 and 5. No, wait, that's dumb. 9 and 4.
What times what's 54? That's
9 and 6.
9 and 6.
I'm sorry.
It's okay. You're fine. It's the end of the day. I understand.
My brain turned off.
Okay. So now I'm going to take out. What can I do with 24?
4 and 6.
4 and 6. Do you guys see how I took out the negative 1s in both of them? Because I'm going to cross those out, and they're going to become what letter? I. Okay, that's important that you do that. So watch. If I simplify this, what is the square root of 9? 3. And what did you tell me the square root of negative 1 is? I. So this becomes 3i root 6. You guys see that? Okay, then I have the minus 7, and then we're timesing all this. What is the square root of 4? 2. What's the square root of negative 1? So I have 2i root what? 6.
You multiply the 7, you get 2, right? You multiply the
So the last thing we're going to do is multiply the 7. No, not about just, because this is one term. So you have 3i root 6 minus 14i root 6. And how can I combine those two?
Correct, 3i.
What's 3i minus 14i?
Negative 11i.
Negative 11i root 6. It's the exact same thing, guys, as if you had x's and y's. We'll practice this more. I know it's the end of the day. It's homecoming week. I get it. We'll practice it more, I promise, the next couple days.
Can I do the document?
Sure. This is probably the hardest part, and it's not even hard. It's just kind of a lot of little things all over the place. So it's like, oh, I got to remember to do that. I got to remember. But you'll be okay, I promise. Okay, almost done. 2 more things. Perform the indicated operations and write the results in standard form. All right, what does this mean?
Foil.
We're just going to write it twice in FOIL. So I have 4 plus negative root 7, 4 plus negative. Don't worry about taking the negatives out right now. Let's just talk for a second. What is 4 times 4? 16. What is 4 times square root of negative 7?
4 square root of negative 7.
4 square root negative 7. What is negative square root of 7 times 4?
4 square root of negative
4 square root negative 7, just like if they were variables. And then what is the square root of negative 7 times the square root of negative 7? What is it? Negative 7. It is the square root of 49, right? Which is 7. So before you try and like taking all that stuff out, guys, remember, if you multiply a house and a house that are the exact same, the only thing that goes away is the house. So now you can kind of look at this and say, okay, I have two real parts. What's 16 minus 7? 9. Plus, how many negative root 7s do I have?
2.
No.
Negative root 7?
Yeah.
2.
No, I don't.
What do you mean?
What number's in front of negative
4.
root 7? So I have 4, and I have, which gives me 8.
Oh, I thought you meant how many like were actually in the equation. So
And then what's the last thing that I can do? Well, how would I get 8i? I'm going to take out the negative 1 that's in here. Because this is really negative 1 and negative 7, right? So it becomes I. So it's just 9 plus 8i root 7. Nothing you guys can't handle. Nothing. It's just a matter of just practicing. It's a little awkward sometimes. Look at this. All this is just the end of a quadratic formula problem. You can simplify first what's underneath the square root. So you have negative 8 plus, well, I'm going to take out the negative 1. And then what's a perfect square and a non-perfect square in 48? 8 and 6, yes, but 12 and 4, bigger? 16 and 3. You can do 8 and 6, but then you'd have to break down 8 again. Like, it's just better to find the biggest perfect square. But now let's go through and just kind of look at stuff we can simplify before we do anything. What is the square root of negative 1? I. What's the square root of 16? 4, right? So this is the same thing as saying negative 8 plus 4i root 3. Agreed?
Yes.
Over 4. Now, I can rewrite this as negative 8 over 4 plus 4i over, like this. If you need to write it out separately so you can see, that's fine. Yes, ma'am.
Do you want us to simplify the denominator?
We're gonna have to simplify. Yeah, that's why I wrote it out separately. What is negative 8 divided by 4?
Negative 2.
So negative 2 plus, what's 4 divided by 4?
1.
So just I root 3. That's the part that you guys will mess up on because you'll forget to simplify. Don't forget. Yes? Okay, last one. No, you're fine. Don't say sorry. I put the teacher copy of the notes up so you guys can look at that as well. Are you following along with that?
Mm-hmm.
Yeah. But just in case you guys miss anything. Oh, my bad. The video's there. All right, you will have a question on a quiz and or test that says use the quadratic formula. We all know the quadratic formula. We've seen it before. You guys get it on your standardized test, so we'll give it to you, but it's x equals what? Negative b plus or minus square root of b squared minus 4ac all over 2a. We have to use the quadratic formula when something doesn't factor nicely. The first thing I would try and do is factor before I do anything with the quadratic formula because it takes so long. The ones that I give you on the test or quiz, you'll have to use the quadratic formula because that's what we're testing on right now. But if I did try to factor this, I'd say 4 times 15, and I try to find the factors of 60 that somehow multiply. It doesn't work. Obviously, that's why we're using the quadratic formula. So, tell me what A is, please. Tell me what B is.
6.
And tell me what C is.
15.
Okay. So now we just go through and we fill in. So I have negative 6 plus or minus the square root of 6 squared minus 4 times A, which is 4, C, which is 15, all over 2 times 4. Questions? Now, Francisco and some others of you, you'll try and simplify everything in one step and show no work and try and save paper. I appreciate you caring about the environment, but I'd like to see your work. So let's go nice and slow. Negative 6 plus or minus. What is 6 squared?
36.
36. Minus, what is 4 times 4?
16.
Times 15.
240.
He has my notes pulled up. 240, we'll go with that. Over, what's 2 times 4? 8. Now, don't worry about simplifying numerator and denominator till the very end. Let's just worry about what's underneath the radical. Let's simplify that. So we have negative 6 plus or minus. Well, what is 36 minus 240?
240. 204. Negative. I have the answer.
I know. I'm just waiting to see if anybody else. So it's negative 204 over 8. Now, let's break down 204. Not Francisco. Let's look at something. If I have 204 and you guys are like, oh, geez, a perfect square and a non-perfect square that goes into 204. Well, 2 into 204 is what?
102.
102. Okay. 2 into 102?
51.
What is it?
51.
51. So what could I break 204 into? 4 and 51. You guys see how I just did that? So I have negative 6 plus or minus the square root of negative 1, 4, and 51. You agree with me?
Yes.
No.
Why not?
Because you got the fourth one. You look like two.
I was trying to find a perfect.
Negative 1 is between negative.
Negative 1 is the negative from here.
Okay.
So when I simplify this a little more, I'm going to take out this negative 1. What is the square root of negative 1? I. And what is the square root of 4? So I have negative 6 plus or minus, woo, 2i root 51 over 8. We okay? I can do one more thing, which is what? Simplify what?
Everything by 2 or like
Right? Look, if I rewrite this, and sometimes it's easier to do, to rewrite it. If I divide 6 and 8, what goes into both of those? 2, right? So I'm left with what?
-3.
Negative 3 over 4. So plus or minus, what goes into 2 and 8? So this would be I root 51 over 4. Can I rewrite that over one denominator? Yes or no?
Yes.
Yeah, I could say negative 3 plus or minus I root 51 over 4. These two things are the same thing. I will not deduct points if you separate versus keep it all together. Sometimes it's easier to separate though, so you can see what you can simplify and stuff like that. Now again, I know I went through that quickly.